Hello and welcome back to the video guys. I hope you are doing great. So far we are doing good and we have covered a lot. We have covered introduction to modeling, linear regression, logistic regression and decision tree. Now in this video we'll be covering naive Bayes algorithm. So first we will see what is a naive Bayes classifier, then how naive Bayes classifier works, then we'll see why or why not this classifier is to be used, and then as usual we'll do an assignment on it. So without further ado, let's see what is naive Bayes algorithm. Now naive Bayes classifier is a classification technique which works on Bayes' theorem of probability. Recall the Bayes' theorem that we studied? Basically it describes the probability of occurrence of an event related to any condition. So our algorithm is based on this theorem and hence it is called as naive Bayes classifier. Now the question is, how does naive Bayes classifier works? So let's understand this with the help of an example. Say we have a data set of weather as shown here and the corresponding target variable, that is play, which is basically suggesting the possibilities of playing a game yes or no based on the weather condition. Now based on this information we need to predict if players will play or not given a certain weather condition. Here we will first create a frequency table like so. This table tells us the total frequency of play in a given weather condition. For instance, in rainy condition, we have 2 yeses and 3 nos. In cloudy condition, we have 3 yeses and 2 nos, and so on. And at the bottom, you can see in total we have 9 yeses and 6 nos. So that is how we create the frequency table. Once we have our frequency table, now from the frequency table, we will calculate the likelihood table like this. So what we are doing here is that we are finding the likelihood of the weather conditions row wise as well as the likelihood of the possibilities of play column wise. So in the first row we have rainy weather in which we have 2 yeses and 3 nos. So the likelihood here would be total games happened on rainy day divided by total games, which is 5 by 14. And it comes out to be 0.35. Similarly, we can find other values column wise as well as row wise as shown here. And don't worry, you don't have to remember all these steps. It is just for your understanding. Everything will be done by R. I'm just explaining the process. Now with the likelihood table, we will calculate the posterior probability using Bayesian equation. And then the class with the highest posterior probability is the outcome of our prediction. For example, we can calculate posterior probability of the possibility of playing provided the weather is sunny. So our equation would be probability of sunny weather provided the play has happened multiplied by prior probability of play happening divided by the probability of weather being sunny. Now we can stipulate these values and can find the posterior probability. So that's in a nutshell how a naive Bayes classifier works. Now there are few pros and cons of naive Bayes classification technique over other classification techniques. So you see we could have used logistic regression or any other technique as well. So the question is, why do we need this? Well, the answer is it is a simple, easy and fast to predict compared to other techniques. And it also performs well in multi-class prediction. So these are the main two advantages of this technique. But as it is a quick and easy method, hence it is also not a very good estimator. The outputs may not be very accurate. It also has an assumption of independent predictors, which in real life is almost impossible to find. For example, temperature being hot and humidity has no dependence in predicting weather. Yet having these drawbacks does not negate its importance. Based on your need, you choose an algorithm. Suppose you are working on a project and the stakeholders want a first cut of your model quickly. So you would not go on creating a complex model in this case, and naive Bayes is a very useful tool to use here. Alright, so that is all from Naïve Baye's algorithm. We have understood the Naïve Bayes classifier, then discussed how does it work. Then we discussed why or why not we should use this algorithm. And now we will build our model in R using Naïve Bayes algorithm.